So at this point, we'll introduce an obligatory math joke. How many numbers are there? 3, 0, 1, and infinity. This joke explains two things. First, why you won't see me on HBO or Netflix anytime soon, and more importantly, how mathematicians think about objects. In general, something doesn't exist. It's a 0. Something is unique. It's a 1. Or there's an unlimited number. That's an infinity. In many ways, 2 is the oddest number. So while this isn't always true, many theorems in mathematics do attempt to prove non-existence, that's a 0, or uniqueness, a 1. So let's consider some non-existence proofs. For example, let's prove that if A minus B equals A, then the intersection is the empty set. Since this is already in conditional form, we know that we can start by assuming that A minus B is equal to A. Now, we'd like to show that the intersection is the empty set, and we can do this by closing all roads, show that there's no possibility that there's something in the intersection. And to do that, we'll use a proof by cases. So let's consider any element x. Now, either x is in A or x is not in A. So if x is not in A, then x is definitely not going to be in the intersection because it's not in one of the sets. On the other hand, suppose that x is in A. By our assumption, the set difference is A itself, and so that means that if x is in A and this is an equal set, then x is also in the set difference. And that means that x is in A and x is not in B, and so again, x is not in the intersection. Now it's good style to summarize what we've done. If the set difference is A, then if x is in A or not in A, then x is not going to be in the intersection, and that means there can be nothing in the intersection, and consequently, the intersection must be the empty set. So again, a useful strategy in math and life, prove it again. And in this case, remember a conditional and its contrapositive have the same truth value. So our contrapositive is if the intersection is not the empty set, then the set difference is not the set itself. So again, it's a conditional, so we can begin by assuming that the intersection is not the empty set. Well, that means there's some element that's in both sets, but the set difference consists of the elements that are in A, but not in the other set. So this element that's in both sets is not going to be in the set difference, and so the set difference can't be the same as the original set.